linear one. What is the meaning of the position vector of a given point A with respect to the origin point O in the direction or in the directed line segment OA, which is starting point is the origin point O and the given point A is its ending point. Then we can say that all position vectors have the same starting point O, 0 and 0, the origin point. Then we denote the position vector OA by the symbol vector A. In the previous figure, we write 8 with 3 and 2, but B -3 and 4. This is the position vectors. Now we want to know what is the meaning of the norm of the vector. The norm of the vector, it's the length of the line segment that represents the vector, like the vector A with x and y. Then the norm of the vector A equal the length of OA line segment, and if we used the law of the distance between the 2 points from middle 3, we deduce that OA equal root x minus 0 all power 2 plus y minus 0 all power 2. Then the norm of the vector A equals the square root of x power 2 plus y power 2. Just for example, if the vector A equals 3 and -4, then the norm of the vector A equal root 3 power 2 plus -4 all power 2 equal 5 length unit, and so on. Now we want to know the meaning of the unit vector. It's the vector whose norm is unity. For example, the vector A equal 3 over 5 and 4 over 5 is a unit vector because the norm of the vector A equal the square root of 3 over 5 all power 2 plus 4 over 5 all power 2 equal 1 length unit. Then we deduce that the unit vector its norm must be equal 1 length unit. But the 0 vector, it's a vector whose norm equals 0 and denoted by vector O or vector 0, where vector O equal 0 and 0 and it has no direction. Assalamu alaikum. We want to talk about in geometry middle 3, lesson 3 and lesson 4 in the geometry. First lesson we want to talk about the measure of the inscribed angle and the relation between the inscribed angle and the measure of the arc. In the opposite figure, the measure of the angle ACB equal half the measure of the angle AMB, because AMB is a central angle and ACB is an inscribed angle. And we know that the inscribed angle is half the measure of the central angle, and since the central angle equal the same measure of the arc, then we deduce that the measure of any inscribed angle equal half the measure of the inscribed arc. Like in this figure, we can say that the measure of the angle C equal half the measure of the arc AB. And we note that the measure of the arc equal twice the measure of the inscribed angle subtended by this arc. Exercise number 1. In the opposite figure, I want to find the measure of the angle N. The measure of the angle N, since NY equal NZ 2 radii, then we deduce that the measure of the angle NZY equals the measure of the angle NYZ equal 30 degree. Then the measure of the angle N equal 180 minus 30 plus 30 equal 120. And the measure of the angle X is an inscribed angle, but N is a central angle. Then the measure of the angle X half the measure of the angle N equal 120 divided 2 equal 60 degree. And he wanted to get the measure of the arc XZ from X to Z. Measure of the arc XZ equal twice the measure of the angle XYZ inscribed angle. If part of Y equal 40 and the other part equal 30, then the measure of the angle Y equal 30 plus 40 equals 70. Then the arc XZ equals 140. And the measure of the arc XY equal the measure of equal twice the measure of the inscribed angle Z. Since the measure of the angle Z, the inscribed angle, equals 180 minus the measure of the angle X equals 60 and the measure of the angle Y equals 70, then the measure of the angle Z equals 50 degree, then the opposite arc to it equal its twice. Then we can take 50 and multiply it by 2, then the measure of the arc XY equal 100. And we must know that any inscribed angle drawn in a semicircle is right angle. Like this figure, the measure of the angle ACP equal 90 degree because it's half the measure of the angle C, half the measure of the arc AB. If the arc AB equal 180, then the measure of the angle C equal 90 degree right angle. And now we wanted to know well-known problem number 1. If the chords intersect at a point inside the circle, then the measure of the included angle equal half the sum of the two measures of the two opposite arcs. Like this figure, we can say that the measure of the angle CEA equals half the measure of the arc AC plus the measure of the arc BD, and the measure of the angle CEP equal half times the measure of the arc BC plus the measure of the arc AD. Then the second well-known problem, if you have two chords inside circle intersect outside it, then the measure of their intersecting angle equal half of the measure of the major arc subtended from its half of the measure of the minor arc, in which both arcs included by the two sides of this angle. Then we deduce that the measure of the angle A equal the measure of the angle A equal half times the big arc, the measure of the arc CE minus the measure of the arc BD. Then this is the rule. The measure of the angle A equal half the measure of the angle C minus the measure of the angle, the measure of the arc BD. And now we want to solve some exercise of these two well-known problems. In the first figure, we want to find the measure of the angle A. The measure of the angle A, inscribed angle, equal half the arc that's subtended by it. Then we can say that the measure of the angle A equal half times 140 equals 70 degree. The measure of the arc AC, if you want to get the measure of the arc AC, you must get the measure of the arc AB. The measure of the arc AB is twice the inscribed angle 60 degree. Then the measure of the arc AB equal 120, and this is 140. Then the sum of the two arcs equal 260. Then the third arc from 360 minus 140 plus 120 equal 100 degree. And now in the second figure, we want to find the measure of the angle C. The measure of the angle C equal 90, because this is an inscribed angle, and the measure of the inscribed angle equal 90 degree, because the measure of the arc AB equal 180, and any inscribed angle drawn in the half circle its measure is 90 degree. Now he wants to get the measure of the angle B. If you want to get the measure of the angle B, then we must find the arc AC. The measure of the arc AC. How? By subtracting 180, the measure of the arc AB equal 180 minus 128 to get the measure of the arc AC. Then we deduce that the measure of the arc AC equal 180 minus 128 equals 52. Then the measure of the angle B equal 52 divided 2 equal 26 degree. And now in figure number 3, we want to get X. You know that X in the measure of the angle B equal half 92 equal 46 degree. Then X plus 1 equal 46. Then X equal 45 by subtracting 1. And we want to get the measure of the arc AB by subtracting the measure of all arcs in one circle equals 360 minus 110 plus 92 to get the measure of the arc AB. And you can solve the remainder questions by yourself by the same way. Homework. Now we want to talk about the inscribed angles subtended by the same arcs in the same circle. The measure of all inscribed angles subtended by the same arc are equal. Then we can deduce that the measure of the angle E equals the measure of the angle D equals the measure of the angle C in this figure, because these three inscribed angles subtended by the same arc اللي هو arc AB. And now note that in the same circle or in any number of circles, the measure of the inscribed angles subtended by arcs of equal measures are equal, like the measure of the angle y and the measure of the angle x. Since the arc DC equals the arc AB, then the measure of the inscribed angle y equals the measure of the inscribed angle x. And we can say that in the same circle or any number of circles, the inscribed angles of equal measures subtended arcs of equal measure. Like this figure, if the measure of the angle x equals the measure of the angle y, we deduce that the measure of the arc AB equals the measure of the arc CD. For example, if you wanted to find the measure of the angle C, the measure of the angle C, to get it, since AB equal BD equal AD, then this is an equilateral triangle, and DC bisect the measure of the angle D into two parts are equal, then each interior angle in the equilateral triangle equals 60 degrees, then this is equal 30 and 30. Now we deduce that the measure of the angle D equals 60, and the measure of the angle ABD equals 60, and the measure of the angle D equals 60. Then the measure of the arc DB equals 60 degrees, then the measure of angle C equal half, is 60 equals 30 degrees. The measure of the angle CPA equal the same measure of the angle CDA, two inscribed angles in the same subtended by the same arc AC. Since the measure of the angle CDA equal 30 degrees, then CBA equal 30 degrees. And now by the same way you can solve the second figure and the third figure and in the homework, and this you can solve this page in your homework.